Hello, I am Professor SHALINI SAHAY from the EC Department, SIRT Bhopal. Today, in this video lecture, I am going to discuss the Butterworth filter. It is an IR digital filter. Now, first we will discuss analog filter approximation, which is a low pass filter and it passes frequency till the cutoff frequency FC, and after that it blocks the frequency, and that is shown in the figure as in stop band. So an ideal low pass filter in which the pass band occurs first and beyond the cutoff frequency the stop band occurs. Now the approximation in the ideal characteristics, where the several approximations have been shown in figure 2. Fp is the passband edge frequency at which reduction has been started, and it is a stop. Fs is the stop band edge frequency after which the filter blocks all the frequencies. Fc lies between Fs and Fp, and cutoff frequency is 3 dB down to the maximum value in the log scale 1/√2 of the maximum value in the absolute scale. Del F is the transition frequency from passband to stop band. Now, the Butterworth filter approximation, the magnitude response of a Butterworth filter is as shown in figure 3. The magnitude response of the low pass Butterworth filter is given by this transfer function. Now, here the some Butterworth filter approximation we have discussed. Now, salient features of the low-pass Butterworth filter. The magnitude response is nearly constant, and it is constant equal to 1 at the lower frequency. There are no ripple in the passband as well as in the stop band. The maximum gain occurs at omega 0 or sigma 0, and it is given by the transfer function as 1. The magnitude response is monotonically decreasing. As the order of the filter n increases, we have shown the response of the filter is more closer to the ideal response. Now we will design using Butterworth approximation. In the design equation, we have following some design steps, where AP is the attenuation passband, it is attenuation stop band, this is the passband edge frequency, this is the cutoff frequency, and this is the stop band edge frequency. In the problem, the specification of required digital filter is given, and it will be asked to design a particular discrete time Butterworth filter. The following steps should be used. From the given specification of digital filter, obtain equivalent analog filter as follows. For an impulse invariance method, here we have omega is equal to W upon Ts. For the bilinear transformation method, here it will be equals to T2 upon Ts 10 omega by 2, where sigma is the frequency of analog filter, it is the frequency of digital filter omega, Ts is the sampling time. Here we have calculated the order n of the filter using the following equation. If the specification are given in dB, then use of equation has been given as n is equals to by this formula. Now step 3, we have calculation of the cutoff frequency, where the cutoff frequency of the analog filter is calculated as, and for the impulse invariance method, again we have used the following equations, and when omega c is not given, then use the following equations, and if the poles are complex conjugate, then organize the poles. And fifth step will be calculate the system transfer function of analog filter by using the following equation. And fifth, in the last step, we have designed the digital filter using impulse invariance method or the bilinear transformation method. Thank you.